Good morning, everyone. I'm delighted to be here in the opening sessions of the Kisako Summit around unleashing the value of sensitive data. This is basically the first industry-wide summit on this topic, and I'm sure many more will still come. I'm Alon Kaufman, co-founder and CEO of Duality, and I'll give a little bit more explanation about Duality and myself as we go. But I'm here basically to discuss today the maturity and the market adoption of different pets. We're going to discuss a little bit about the history of the field, where we stand today in terms of customer usage and deployments, and where this field is moving in the future. But let me start off by framing the basic question or challenge around this topic. We live today in a world where there's a huge clash or dichotomy between the value and the promise the data economy is offering versus the challenges around privacy and security in these topics. And this crosses all different levels, on a nation state level, on an enterprise level, on a personal level. And I want to go just a few examples to emphasize the point before we dive into the specific solutions that are out there today and how they deployed. So, we're standing today in the middle of 2021 after a year and a half of fighting the COVID pandemic. Clearly, if all nations, if all healthcare organizations, if all healthcare providers would have shared data freely when this pandemic started, we would be today in a much better situation in terms of fighting and stopping the pandemic, researching and developing vaccines, and of course also testing their effectiveness. However, at the same time, we as individuals, I'm sure, would not like our data to be just traveling all over the world without any control what's going on with it. At the same level, enterprises today are driving a lot of business value out of using methods of AI, machine learning, and so on. And they do this with analyzing the data they have in their control. So for the last 30 years, they've been collecting data, applying to it BI tools for the last 15 years, doing data science and machine learning for the last 10 to 5 years, and deriving a lot of value. But imagine just that they could derive value not only from their data, but also data of other enterprises around them. This is, of course, desirable, but enterprises are not doing this in many cases because there's legal concerns that don't allow them to do that. But even beyond that, a lot of them are not willing to share the data because of their own business privacy and protecting their own IP. And of course, as individuals, we all enjoy a world where we get better personalized medicine and better personalized ads and better personalized offers. But at the same time, we all very much concerned about our privacy and don't want our data out there in the free. So it's clear that there's still way more value this data economy era can offer, but at the same time, these privacy and security concerns are rising, and that's exactly one of the challenges that in order to enable this data economy to bloom, we have to solve the legal, security, trust, and ethics topics around the data. And that's what the next 3 days are all going to be about. How can you at the same time create value and allow the businesses to advance while protecting the data, protecting privacy and trust. On the technology level, you have exactly this same dichotomy. So the technologies that are used to create the value, to reveal these patterns, are technologies of machine learning and data science, which are all about finding patterns, finding data, or people like to say, finding the needle in the haystack. On the other hand, the security methods are all about hiding and protecting, or one could say hiding the needle in the haystack. And you have this kind of inherent clash of finding the needle versus hiding the needle, which PETs, privacy-enhancing technologies, that we're going to be discussing in these coming 3 days are all about. How can you both protect the data and analyze it at the same time? As I promised, I'll give a few words on my background. So I actually come from these exact two streams of the machine learning side, as well as the encryption and security side. I did my PhD in computational neuroscience, basically doing neural networks and machine learning. and then spent 15 years in the industry basically solving business problems by using various types of data science. And as part of this, I joined RSA, the security company, as their director of data science. Where at RSA, I continue to do classical data science work, building models that can better detect fraud in financial institutes and do better identity theft models and so on. But at the same time, I had responsibility on RSA Labs, which is the encryption side of RSA. And that's where it became clear that the security challenges don't go hand by hand with the machine learning world, and they actually clash. And throughout this tenure, I met the Duality co-founders, and that's exactly what drove to found Duality. We are a combination of founders that come from world leaders in the space of encryption, and specifically homomorphic encryption, along with data scientists from the industry that came together to basically solve this problem of unleashing the value or unlocking the private data in data collaboration initiatives. Now, this problem is not just a theoretical problem. There's businesses today that are being impacted by the different types of data privacy challenges. And you see it across multiple industries in multiple places. Here are just some examples where companies that are built on the fact that they work globally and work on data from multiple countries are now going to be impacted by the different localization and the SHRM privacy rules. We've discussed the COVID challenge, how basically the world could not respond as it would like to because of the various types of data privacy regulations. And we all know that in the space of financial crime, the world is losing out on this, and we're losing billions and billions of dollars to criminals because banks cannot simply work together and collaborate in fighting against the fraud. And as absurd as it may sound, even in terms of security, some of these data privacy rules are basically impacting our public security. Now, this problem is going to continue because the more the data science world and the more this world of AI and cloud advances, the more rules, the more regulations, the more privacy challenges will be, and more impacts will happen, and more companies will start really losing their businesses. Now, the problem is that this is happening because the traditional methods that are used are simply not good enough. Companies that today use a trusted third party, it's clear that there's nothing like a trusted third party anymore. You know, even governments and various types of shared pods cannot save your data. Anonymization is not really working. You can strip out the private information, but from the data itself, you can derive so much more. So, we can take, if companies can today analyze your voice and understand your mood and understand if you're in love or not, and understand if you're desperate or not, that's even without knowing your name or who you are or whatever. So clearly, just stripping out identifiers is not good enough. And also the classic encryption methods, which are all around protecting the data, are good to protect the data, but not when you come to use it. And all what we've been talking about up until now is how can you actually work with the data, utilize the data at the time while you're still protecting it. And this is where these new technologies called privacy-enhancing technologies come into place. And throughout the next few days, we're going to hear about many of these types of technologies. And I chose just to highlight four. There's many others. There's trusted execution environments, there's synthetic data and others. But I just chose to highlight these four methods where each of them solves a slightly different problem in the space. So the good news is that all these different pets solve different problems, and they're not all overlapping. They're actually complementary in many senses. The bad news I have to give you is that there's still a lot of confusion in the market and a lot of desperation from customers to understand what technologies to use for what problems. And part of this talk and part of these 3 days is to help to demystify that. What I want to do today is actually talk mainly about homomorphic encryption. homomorphic encryption is probably the holy grail of these different types of PETs, but also the one which many customers still think that is not mature enough or not practical enough to use. And I want to focus the rest of the talk on the recent advancements in the space of homomorphic encryption and what customers are doing with it. So let's start by looking at how a classical homomorphic system, homomorphic encryption system would look like. So the first thing is you would like to have multiple data owners working together, where each of them has their own secret key and they can go and encrypt the data. Encrypted data is basically taking the data and locking it in a safe, and only they have the secret keys. So only they keep the key to the safe. Now, while this data is encrypted, while it's in the safe, you would like to be able to apply to it different types of analytics from machine learning, AI, and also standard types of queries and statistics. You would like to be able to link data sets together, join them, enrich them, all under encryption, of course. A desirable system will be based on technology that has standardizations from a classical standardization body, which exists today in the space of homomorphic encryption. And you also want the strength of the encryption to be validated by the community, and the way this is done in the encryption methods is typically by open sourcing the encryption technology so that the community can validate it. In addition to that, as a data owner using such a system, you want to make sure that you don't have to trust any third party or any hardware to protect your data. So that the key that you own, the secret key that you encrypted the data, is the only thing that can ever decrypt the data or the outcome of the computations. In addition to these things, a system like this definitely should meet the different privacy regulations that exist so that legally you can use it, as well as in terms of the encryption strength, it should be what's called post-quantum cryptography, meaning that the different challenges that quantum computers pose on classical encryption methods do not apply here. Now, these kinds of systems, although they've been a dream for many years, are actually become practical to be used today, and they support a very wide range of types of computations. You can do today queries, you can run statistics, and even machine learning modeling and inference models. Now, this for many years wasn't really proven to be done until just in the last 3-4 years that some of these things have been cracked. And correctly so, people that talk about homomorphic encryption remember it as a technology that was not mature or practical to be used. And that's because in 2009, when this technology, or when this was proven scientifically, it really, to multiply 2 bits took 30 minutes. So obviously this wasn't practical for any kind of commercial use, but there's been a lot of progress, as you can see along the years. Open sources have been released to the public. The first one in 2014, Palisade, already showed a dramatic improvement in terms of the performance. In 2019, we released a system that does large-scale genome-wide association studies on thousands of patients and 500,000 variants. There's been advancements in terms of accelerating it with hardware. Just last year, in collaboration with Intel, we got another order of magnitude improvement. And in the recent year, there's been a huge effort, including things that we'll hear from DARPA in these coming days, to go and really build accelerated hardware that will probably accelerate by another 3 orders of magnitude. We lie today in the place where there's 9 open source homomorphic encryption libraries and multiple vendors starting to operate in this space. But if we simply look at the numbers, over the course of the last 15 years, or more or less 15 years, there's been a 10 orders of magnitude performance. So essentially, every year and a half, there's another order of magnitude improvement, and that's really where this field is moving. Today, it can be used in multiple use cases, and in the future, as we improve, more and more use cases will open. I want to move today to what is being used in these kinds of systems and where the state of the art is in terms of deployments. So first of all, homomorphic encryption is still not a system that you can simply throw over your whole data warehouse and expect all your legacy applications to continue to work as usual, or expect your favorable data science libraries and platforms to simply work on top of encrypted data. On the other hand, based on the advancements I just showed you, there are specific use cases that are very practical and are being used today. And here are 4 examples. By the way, we have a dedicated session on these specific examples called Homomorphic Encryption in the Wild, use cases and case studies, where we dive into each of this with a 5 to 8 minute discussion with the different partner or customers that are involved in the projects. But you can just see an example here. We use our query capabilities in this world of financial crime, enabling banks to basically collaborate together in fighting back financial crime. In the healthcare world, healthcare organizations are very reluctant to share the data. In many cases, everyone thinks their data is more valuable than the other healthcare provider. And so in that case, there's not only the privacy challenge of collaborating, it's also allowing the healthcare provider to maintain control on its own data and how it's used. And one of the case studies that are used there are in the space of real world evidence, or in the ability to combine clinical data and genomic data together from 2 different arms in order to analyze them. Examples of machine learning include the ability to train models on data coming from multiple organizations. As we all know, in the space of cyber attacks or any kind of criminal attacks, you want to identify the new attack patterns as early as possible. So if multiple organizations can combine their data together and retrain their models on this data, it will help everyone fight fraud or fight cyber more effectively. So that's an example of doing machine learning training on data from multiple customers, of course, without ever disclosing the data itself. And specifically with Intel, there's a huge project around deploying machine learning models that can serve encrypted data. So basically accelerating data science and machine learning capabilities that offer their services on data that they'll never be able to see, which enables this whole data science of model monetization in the cloud jump to another level of commercialization. As I said, more on this in our specific session that will be led by our head of product strategy in the on-demand sessions. Coming to close to the end, I want to talk a little bit about where I see this field going and what we should expect in the coming years. So clearly, more and more organizations are using data science as we know today and creating a lot of value. But the minute that these organizations can start doing collaborative data science with other organizations, as in any kind of network, the value will grow exponentially. And I'm not just talking about banks collaborating with banks. I'm talking about banks collaborating also with insurance companies and with healthcare companies and with telcos and with retailers and so on. So just imagine this world where organizations can not only work on their own data, but work collectively with other organizations. This will definitely drive a huge value creation in the space of data, and also a lot of competition between the different companies that can really go and do it. In parallel to this, as we just saw in the previous slide, the performance of these privacy-enhancing technologies will continue to improve. And the more it improves, more and more use cases will be opening. As well as the improvement in the data science and improvement in the pets, also privacy regulation and legal constraints are going to continue to rise. And for organizations to be able to operate in this regulation landscape and under these legal constraints will be a huge challenge. Those that will adopt privacy-enhancing technologies at the beginning will be their secret sauce to continue to drive their business and grow this business under these regulations. And in the coming years, this will even become the industry norm of working in a collaborative way and at the same time protecting your data. Let me end my call in trying to provide to you the takeaways which I expect you got out of this call and you'll get out of this summit. And these are basically the three messages I want you to take home. First of all, when you think about these PETs, these privacy enhancing technologies, don't think about just improving the way you do things today and lowering your total cost of ownership and increasing your efficacy today. Think also about what new business opportunities this can enable. The second thing is that PETs are ready for production. As I said, not in all use cases, not in all scenarios, but happy to have a deeper discussion when and how to deploy them. And the third thing, which is going to be confusing still for the coming year or two until the field matures more even, is how do you know what, if and what PET do you need? And here basically we have a cookbook to help our customers guide them. But the three main questions you should be asking yourself are the following. Do you have a need to protect data while it's in use, meaning while analysis? Or do you find the need to control the data or how it's used? Do you have multiple parties or within your organization or between organizations that need to work on the data in a secure way? And the third thing which will impact the type of PET is, do you know what type of data science and analytics you need to apply to the data and the required accuracy from these types of computations? These three can help guide you towards what type of PETs you should be looking into. And obviously, I would be happy to meet you and continue the session in our booth, and we can dive into some of these deeper questions in the future. Just before I end, I want to announce that you're all invited to come and try out the Duality Sandbox. You don't have to be a data science expert. You don't have to be an encryption expert. You don't even have to have data and models. Everything is ready for you in our sandbox. Just log in or send us an email and you can try out some of these recent PETs and see how it works and if it fits your organization. And with this, I want to thank you all for listening and open up for some questions.